Today we're going to do section 7.4, and this is polynomial equations in factored form. I'm not going to write that out, that's way too long, but a polynomial is written in factored form when it is written as a product of factors. And so we're going to highlight factored form here. And if we go back and think about a polynomial, we had standard form, which is the following. Alright, standard form is something like x squared plus 2x, right? Our exponents, they get smaller, so we went from 2 to 1. And our leading coefficient here would be 1, and that's the gist of that. You know, another example of standard form could be something like x squared plus 5x minus 24. And now we can factor both of these and put them into factored form. And so last time we were looking at what happens when we take products of polynomials, multiplying out polynomials. And so if we want to take the reverse of that, start with something like this and reverse that, we can factor out an x on both of these terms here. And then in parentheses, put an x plus a 2. Right? Because if we multiply this x out, that's going to be our x squared. And if we multiply this x here, that's going to be our 2x. Likewise, we could take something like x squared plus 5x minus 24. And last time, or 2 times ago, we learned about the FOIL method. This actually breaks down into x plus 8 multiplied by x minus 3. Right, I'm gonna teach you all about how to do that today, how to break this down. It's actually a pretty straightforward process, a lot of guessing and checking, but once you master it, get more familiar with numbers, you should be pretty good at it. All right, but just to solidify that, if we do our FOIL method, first we got x squared, then outside we got minus 3x, inside we got plus 8x, and outside we got minus 24, or x squared plus 5x minus 24. So that does indeed line up. And so first we're going to talk about what is known as the zero product property. And so the zero product property is if the product of two numbers is 0, so if the product of two numbers equals 0, then at least one of the numbers is 0. And that makes sense, right? So if you have two numbers, a and b, and you multiply a and b together and they equal 0, then you know that one of those two numbers has to be either equal to 0. So either a is going to equal 0 or b is going to be equal 0. Or they both can equal 0, right? Because a multiplied by a 0 would equal 0, b multiplied by a 0 would equal 0, and 0 multiplied by 0 would equal 0. What I'm saying is now is we could take something like this and solve it. So let's look at 2x multiplied by an x minus a 4 is equal to 0. Since this is equal to 0, we know that the following must be true. Either 2x, this factor right there, is equal to 0, or This other factor, x minus 4, is equal to 0, because when they multiply together, they're equal to 0. Right? It's the same thing as here. Our a is a 2x, and our b is the x minus 4. So in this first case, we would divide both sides by 2 to get x is equal to 0. On this second case, we would add 4 to both sides to get x is equal to 4. And so in this first problem, x is equal to both 0 and 4, and what we call x are the roots. So the roots are x is equal to 0 and 4. Let's do another example. Let's take a look at x minus 3 multiplied by x minus 9 and set that equal to 0. Once again, we're going to have two factors here. We have an x minus a 3 and we have an x minus a 9. And when they're multiplied together, they equal 0. So either x minus 3 is equal to 0 or x minus 9 is equal to 0. So we would take x minus 3 equal to 0 or x minus 9 is equal to 0. And now we can solve both of these by first on the left side adding 3 to both sides and getting x is equal to 3. And then on the right side we can add 9 to both sides to get x is equal to 9. So I'll leave that up for just a second. Alright, and I want to go ahead, I want to practice a couple more of these, so we'll leave those ones up there. We're going to do a similar one here on the left side, so we're going to take 3x, multiply that by an x, or let's do a 2x minus 2 is equal to 0. And so we have our two factors here. We have the factor which is 3x, and we also have the factor which is 2x minus 2. So we can set 3x equal to 0, or we can have 2x minus 2 is equal to 0. And so x can equal 0 on the left side if we divide through by 3. 0 divided by 3 is 0, so x is equal to 0. Here we're going to first add 2 to both sides, so we're going to get 2x is equal to 2, and then we're going to divide 2 on both sides to get x is equal to 1. Alright, so the roots on this one, x is equal to 0, and x is equal to 1. Right, I'm going to do one last example like this, so let's take a look at z minus 4 and 2z plus 6 is equal to 0. So we have our root on the left and our equation on the right. And so we're going to have z minus 4 is equal to 0, or 2z plus 6 is equal to 0. Solve this blue one first by adding 4 to both sides. We're going to get z is equal to 4. Or we can solve this left-hand side by subtracting 6 on both sides first to getting 2z is equal to a negative 6, dividing by 2, and getting z is equal to a negative 3. So the roots on this one z is equal to, and I always like to put my smaller number first, so we're going to start with the negative 3 and then the positive 4. And so if 2 or more if two or more of the roots equal the same number, then the equation has repeated roots. So if you're solving out those equations like we were just doing, the first one was, say the first one is equal to a 4, and the second one you get x is equal to 4, then you know that they are both 4, so there's only one root, right? So we're going to do an example with that real quick. We're going to solve each equation just like we were doing. We're going to take a look at 2x plus 7 multiplied by 2x minus 7, and we're going to set that equal to 0. And so we're going to solve this just like we've been doing. We're going to set up a left side here of 2x plus 7 is equal to 0. And we're going to set up our right side here with 2x minus 7 is equal to 0. And so if we solve both of these, we're going to first subtract 7 on both sides on the orange, and that's going to be 2x is equal to a negative 7. And so that's going to be equal, after we divide by 2 on both sides, x is equal to a negative 7 halves. And then on the right side, we're going to add 7 to both sides and get 2x is equal to a positive 7. Divide by 2, divide by 2, x is equal to a positive 7 halves. So these are not repeated roots. Our two roots are x is equal to plus or minus 7 halves. And now for our second example, we're going to take a look at something like x minus 1 squared is equal to 0. So if you have x minus 1 squared, you can actually multiply those out, right? So that's going to be an x minus a 1 multiplied by an x minus a 1, and that is going to equal 0. And so we can set both of those equal to 0 by doing the following. We have a left equation, which is going to be x minus 1 is equal to 0, and a right equation, which is going to be x minus 1 is equal to 0. Well, those are the same equation, but just so we're not crazy, let's solve both of them. So the first one, we're going to get x is equal to 1, and let's solve the second one. So that's going to be a plus 1 plus 1. X is also equal to 1. So you don't need to write that x is equal to 1 twice, because this is what we call a repeated root. So actually, we can just say the answer is x is equal to 1. Right? So our final answer on the first equation was plus or minus 7 over 2. Our answer on the second equation is just 1. All right. And then finally, we can get, completely crazy and do something like x plus 1 multiplied by x minus 3 multiplied by x minus 2 is equal to 0. The only difference between the first 6 that we've done in this one is that instead of having, a first and a second equation, we're going to have a first equation, a second equation, and a third equation. So our first one is going to be x plus 1 is equal to 0. If we solve that, minus 1 on both sides, we get x is equal to a negative 1. If we take our next equation, x minus 3 is equal to 0, add a 3 on both sides, that's going to be x is equal to a positive 3. And then finally, if we have our last equation, x minus 2 is equal to 0, add a 2 on both sides, x is equal to a 2. We check to make sure if any of the roots are repeated. None of them are the same number, so we're good to go ahead and move on. All right, I signed this on the homework last time, but there was some issues on it, so I want to look at what we do if we factor out the greatest common factor. Otherwise known as the GCF. And so if we look at something like 4x squared plus 24x cubed. So we have 4x squared plus 24x cubed. So if we look at both of these here, if we look at just the number aspect, 4 and 24, the greatest common factor between these two is just a 4. They're both divisible by 4. So let's pull both of those out and write a 4 there. And then if we go ahead and look at our x's, this one has x squared, this one has x cubed, right? 2x's is going to be bigger than 3x's, so we're going to pull out an x squared on both of those. And that's what we have. Right? So if we end up pulling those out on both, what do we have left here? So out of a 4x squared, we have nothing. So that's just going to be a 1. And we're going to add to that, well, 24 divided by 4 is going to be a 6, and an x cubed divided by an x squared is just going to be an x. All right, so that's what it means to look at the GCF, because we first said that the GCF of the number 4 and 24 is equal to 4. So we pulled a 4 out of both of those numbers. And then we said that the GCF of x squared and x cubed was x squared. So we pulled an x squared out of both of those. So now let's ramp up what we were doing a notch and solve the equations by factoring. All right, so the first one here is going to be 2x squared plus 8x is equal to 0. And now, if this would have been a problem I would have given you, just last week, you wouldn't have been able to solve it. But now that we know how to factor out that GCF and solve, these polynomial equations when they are equal to 0, we can very easily solve this problem. So let's go ahead and factor out the GCF here. All right, if we look at our 2x squared and our 8x, in this first one, we can take out a 2. 8 is divisible by 2, so let's pull out a 2 here. And then if we look at our x's, this first one has an x squared, the second one just has an x, so all we're able to pull out is 1x. And then in parentheses, if we have a 2x squared and we're pulling out the 2 and the x, all we have left is one of our x's. And we're going to add to that. 8 divided by 2 is going to be 4. And then if we pull out the x, that's all we have left. So we have now 2x multiplied by x plus 4 is equal to 0. And now we're just going to set up our two equations like we have been doing. So we're going to have a 2x is equal to 0, or we can have an x plus 4 is equal to 0. So solving this first one, we're going to divide by 2, and get x is equal to 0. The second one, we can subtract 4 on both sides to get x is equal to a negative 4. And on each one of these, you can always go back and double check by plugging your answer in. Right? You can plug this x equals 0 right back in up there, and that should, solve the problem. All right, let's do a second one. Let's look at a 6n squared is equal to a 15n. All right, so we don't have anything equal to 0. But that's okay, because if we subtract 15n on both sides, you're going to get a 6n squared minus a 15n, those don't combine. And if you take a 15n minus a 15n on this right side right here, that's just going to be equal to 0. So now all we have to do is factor. So if we factor out, let's look at 6 and look at 15. The GCF of 6 and 15 is equal to 3. Right? So we can pull a 3 out of both of those. And so if we do that, 6 divided by 3 is 2. 15 divided by 3 is 5. And then if we look at our n's here, the GCF of n squared and an n is equal to just an n. So if we pull out an n out front on this first one, we're going to have just an n left, and on the second one, we're going to just have nothing left. So our factored form is going to end up looking like 6n squared minus 15. Oops, no, my bad. Our factored form is going to be this bit, so that's going to be 3n multiplied by 2n minus 5 is equal to 0. So we can now set up our two equations. So we have this equation on the left. We're going to have this equation on the right. And so we have 3n is equal to 0. Or we can have 2n minus 5 is equal to 0. And so we'll divide by 3 on both sides here to get n is equal to 0. Or we can add a 5 here to get 2n is equal to a positive 5. Divide by 2, divide by 2, n is equal to 5 halves. All right, I want to do another problem like that to really just hammer this idea home, and then that's all I'm going to have for you today. So let's just look at something a little more straightforward. It's going to be an a squared plus a 5a is equal to 0. All right? If we look at all of this here, there's an a and an a here. This 5's by itself, so we're not going to do anything with that 5. But if we pull an a out of both of those, we're going to have an a out in front, and down here we're going to have one a left. And then over here we're going to just have our 5, right? Because if we multiply this a through, that's going to be our a squared. That's going to be our 5a. And that's going to be equal to 0. Then we can set up our two equations. So we're going to have an a, and we're going to have an a plus 5. So if a is equal to 0, oh, that was simple enough. That's solved. Or we could have an a plus a 5 is equal to 0. And so if we subtract 5 on both sides, a is equal to a negative 5.